In this video, we're going to talk about sine, cosine, and tangent ratios. So those buttons on your calculator that are 2 spaces above your 7, 8, and 9. So it says SIN, COS, and TAN. So we're going to use those functions on our calculator. So first, turn your calculator to degrees. So hit the mode button and turn it to degrees. We're going to be talking about trigonometric ratios, so trig ratios for short. So it's the ratio of the lengths of 2 sides in a right triangle. So a ratio, remember, is a fraction we can set up and we can reduce that fraction. So we're going to be using these ratios to find the missing side lengths, or we could be using it to find the acute angles themselves, so not the right angle, but the other 2 angles in our triangle. There are 3 of them. The first one is tangent, and it deals with it's the opposite over adjacent, or you can think of O over A is kind of a quick abbreviation of that. If we're talking about angle A right here, the side that's opposite angle A is this green one. The side that's adjacent, so adjacent is next to or connects it to the right angle. The next one is sine, and sine is opposite over hypotenuse. So if we're still talking about angle A, the side opposite this is my green one over here, so BC, so whatever that length is. And then my hypotenuse will always be across my 90 degrees. Next is cosine, so we abbreviate it COS, and it is adjacent over hypotenuse, so that would be this blue side, so adjacent over hypotenuse. So realize that if I was doing it based off of angle B, that the blue side over here would now be opposite and the green side would be adjacent. So it does matter which angle you are talking about. We're going to first do the first one together, and then you're going to set up the second one. This is basically just setting up the different sides of how the ratio is set up, and then reducing your answer choice. So sine is opposite over hypotenuse. So for my angle J, that would be this 24 over the hypotenuse, which would be my 40. When I reduce this, I get 3 over 5. For the cosine then, I am using adjacent over hypotenuse, so that would be 32 over 40. And this reduces down to 4 over 5. For the tangent, since we're still based off of angle J over here, we have opposite over adjacent, so that would be my 24 over 32. This reduces to 3 over 4. So now when I switch to my blue, you can see that this is for my sine of K, the cosine, and the tangent of angle K. So I'm basing it off of angle K over here, so I'm switching my colors. So if I want to do the sine of K, I need to do opposite over hypotenuse. So my opposite is the 32, my hypotenuse is the 40 this time. My 32 over 40 reduces to 4 over 5. Next, when we're doing the cosine of K, cosine, remember, is adjacent over hypotenuse. So adjacent is my blue adjacent, so 24 over 40. From what we saw before, this reduces down to 3 over 5. For the tangent of K, so I'm starting at my angle K, opposite over adjacent, so that would be my 32 over 24. This reduces down to 4 over 3. One thing you might want to notice is that when we have the sine of J, because the adjacent and opposite sides are flipping around when we do the angle K, that the cosine of K and the sine of J end up with the same number. And same thing with the cosine of J and my sine of K end up with the same answer. And if you notice about the tangent of both of them, that the tangent answers for both of those angles are slightly different. They are reciprocals, but that's because the opposite and adjacent are flip-flopping, so it becomes the reciprocal answer. So now I'd like you to try the second picture. I don't think on these you have to really reduce any of the fractions, since 8, 15, and 17, nothing reduces with each of those. But go ahead and work out your answers. When you're ready to check your answers, push play. Alright, so when you're checking your answers, this is what the first 3 answers should be. And they come from those adjacent, opposite, and hypotenuse sides. Remember, the sine is the opposite over hypotenuse, so that's where that comes from. The cosine is adjacent over hypotenuse. And then your tangent is opposite over adjacent. So next, for the sine, cosine, and tangent of angle K, that I put in blue. So you can see now that my opposite and adjacent sides change, the hypotenuse stays the same. So remember, sine is the opposite, so that's this part over here, over adjacent, so 8. Oh, sorry, opposite over hypotenuse is my sine. Cosine then is our adjacent over hypotenuse, so 8 over 17, and my tangent is opposite over adjacent. If you are paying attention right now and you're listening to me talk, put a little smiley face over here on your notes, and I will give you a little bonus point on your test. All right, so just like I have up here at the very top, you need to label the sides in relation to the angle, so adjacent, or opposite, adjacent, and hypotenuse in your picture. So in ours, the 32 is my angle, so the 11 is my opposite. I have my x is my adjacent, and then this other side is my hypotenuse, so I know which pieces I have. So I have opposite and I have adjacent, and the ratio that uses both of those is my tangent. So I need to do the tangent of my angle equals my opposite over adjacent. So that means I'm going to have tangent of 32 degrees equals my opposite, so 11 over adjacent is my x. So this is where I say to make a proportion. So what you want to do is put the tangent of 32, because that's really just a number itself in the calculator, over 1, and now we can cross multiply to solve this. So I'm going to take x times the tangent of 32, and then I'm going to take 1 times my 11, which ends up being just 11. On the left-hand side, if you want, you can type this in your calculator. And when you do that, you get 0.6249. Double check to make sure you get that with your own calculator. And then remember, just to get rid of this from the x, we have to divide both sides by this number. So what I suggest that you actually do is, instead of change it to the decimal, leave it as the tangent of 32. So when you divide it, this is really what you're going to type in your calculator. Then we get a more accurate number, so we'd get 17.6, and that would be it for our x. All right, so I'd like you to try the next one on your own. So remember, label the sides, figure out which of the ratio uses those two different sides that they give you, so for the x and the 13, and then set it up, cross multiply, and then solve for x. In this one, again, you also end up using tangent because we have opposite and adjacent for the x and the 13. So this is what our equation would look like. Since we need to do opposite over adjacent, we have our x over 13. When I put this over 1 and then you cross multiply, we end up taking our 13 times the tangent of the 56 equals our 1 times x. So just our x. So all we have to do on this one is just type this other part into the calculator. So when you do that, you get 19.27.